Okay, so welcome to the first example in section 5.2 that we did not cover today in class. What we're going to be looking at is we're simplifying an expression that has a radical in the denominator. However, it looks a little bit different than problems you've seen before. Now, typically, you've been used to dealing with a problem like this, where let's say we've got radical 2 in the denominator. In order to rationalize that, as you know, you just multiply the numerator and the denominator both by root 2, which will then simplify that into 2 root 2 over 2. And you could even go further and cancel these out and just end up with root 2. But what we're doing is we're rationalizing our denominator. Now, here, if we just tried to multiply this by root 3, we're still going to end up with a radical in the denominator. We'd get it because we'd multiply 5 by root 3. So it's not just as simple as multiplying your denominator by a single radical, as in this example down here. So it's a process that you have to go through. What we're actually going to be doing is we're going to be taking the conjugate of our irrational number. So if you look at this right here, we've got a kind of a mixed number. It's got an integer, real or rational portion, and then an irrational portion. So this type of number has a conjugate, and the conjugate of this number is just 5 minus root 3. You'll remember conjugates from last chapter. We did conjugates of imaginary numbers and also like this, conjugates of these mixed numbers. What you're going to want to do is to rationalize this problem, you're going to multiply both the numerator and the denominator by the conjugate of your denominator. So you're going to end up taking this fraction and multiplying it by 5 minus root 3 over 5 minus root 3. Let me go ahead and work through the steps here for you to see. So you'll see right here, like we just said, the conjugate is 5 minus root 3. So to set your problem up, you're going to take your original expression and multiply it by the conjugate over the conjugate. Now, when you multiply this bottom part together, you're going to notice that again, this matches your difference of squares pattern right here. You've got a term plus another term times a term minus another term. So if you remember from your difference of squares, when you had a plus b times a minus b, that just equaled a squared minus b squared. This is our difference of squares pattern. You'll notice this has been popping up a lot in a lot of the work that we've been doing, so it's an important one to remember. So when you have 5 plus root 3 times 5 minus root 3, you can just say that that is 5 squared minus and then root 3 squared. And what you're going to do is you're going to end up with 5 squared is 25 and root 3 squared is just 3. So you end up with 25 times 3, you get 22. So notice, multiplying your denominator by its conjugate gives you this nice whole number in the denominator. You get rid of your radicals. Because you turn it into this difference of squares form, you're always going to have a nice integer or whole number as the denominator. And what happens if you look at the numerator, when you multiply 1 times 5 minus root 3, you're just going to end up with 5 minus root 3 on top. So your problem is going to be 5 minus root 3 over 22. Again, the key here is remembering, don't just do something like multiply it by root 3. That would not get rid of the radical. Your goal is to get rid of the radical in the entire denominator. So multiplying it by the conjugate is going to do that. When you multiply by the conjugate, remember the difference of squares pattern.